Hello, in this video we'll do a little review from section 5. We're going to do a few of the straight line equations, but we're actually going to start off with another one of those quick activities, playing little games, looking at an original line and then comparing that to a line that is parallel to the original and then one that is perpendicular to the original. And this is just something we really want to get used to. If you've been getting into the Section 5 take-home and book homeworks, you see they really like to hammer these ideas. So first things first, if I start you off and say my original line, number 1, has a slope of 3/7. Well, what do I know about my line that is parallel to the original? The point we want to make first is that parallel lines have the exact same slope as the original line. So that would also have a slope of 3/7. When we come to a perpendicular, that's where we talk about that idea of the negative reciprocal. And this can definitely goof people up the first couple of times they see it. The idea of the negative reciprocal is whatever sign you start with, you get the opposite sign. You start with a plus, I'm going to finish with a minus here. In a moment, we'll see one that starts with a minus, we'll finish with a plus. The whole idea is you're hitting it with an extra negative. If you already had one negative in the first place, that second negative becomes a positive. The second part is the reciprocal, which really boils down to the flip. So here, starting with 3/7, the flip of that would give me 7/3. So my original line has a slope of 3/7. My perpendicular would have a slope of negative 7/3. Let's do this again. Number 2, what if my line, my original line, starts off with a slope of -4? Well, parallel still has that same slope, -4. But then when I do my perpendicular, well, first thing, I'll hit it with an extra negative. That negative will become a plus. And then I need to do a flip. And this is where some people, how do you flip a whole number? Remember, we could always put a whole number over 1. So 4/1 will flip to 1/4. So that's the idea. As long as we know the original line slope, we can always get the parallel or perpendicular line slope by just going through this process. But now let's just do 2 more like this. Number 3, let's say my original line, instead of me giving you the slope, what if I tell you that it has an equation, y equals 5/3 x plus 6. Well, this is where we want to recognize we're in y equal mx plus b form, especially after we do a lot more in section 6, a lot of graphing straight lines. We realize the importance of this form because this is how I can find my slope. This will give me that the slope of this original is 5/3. And now, just like we were doing earlier, now that I know my original slope, I can quickly move through the parallel and perpendicular situations. That if I have a parallel to this one, it would still have a slope of positive 5/3, and then the perpendicular would have a slope, the negative reciprocal, so that becomes negative 3/5. One more like this. Number 4, let's start off. Let's look at, let's do 8x plus 3y equals 15. Again, in section 6, we've seen a lot of this. The line starts in this form. We have to put it into this form. So let's put this into y equal mx plus b form. It's not exactly the same, but it's a little bit like when we first started solving equations. We recognize the form. Certain equations are just ready, put the x on one side, get your constants on the other. Other problems, we'll get rid of the parentheses first, combine like terms first. That's kind of a similar situation here. This one was perfect, ready to go. There's my slope. This one needs that little bit of work first. I'm going to subtract 8x from both sides. I get 3y is negative 8x plus 15. Divide everything by 3. Over here, that cancels. I get y equals. Over here, that I'll leave as minus 8/3. X still there. And then the 15 over 5 will 15 divided by 3 will leave me with a 5. Now I'm just like I was up here. There's my slope. My slope of my original line is -8/3. And if the original line has a slope of -8/3, so does the parallel line. And then the perpendicular, the negative reciprocal of that, will become +3/8. So again, folks, like I said, just a quick little exercise, making sure we're clear on this. And then to continue our review, we're just going to do 3 problems. Well, a couple of them have multiple parts, but for all of these, we are trying to find the equation of the line. And each problem, we're going to be given different pieces of information. And before we even start looking at any of them, this is where you have to realize we're not trying to memorize a process for every little individual situation. We're trying to look big picture. How do we solve this puzzle? So before I give you any information, what's the key here? When we were graphing lines, we wanted them in that y equals mx plus b form. Just come back here for a quick moment. In these particular problems, the b was irrelevant. We just cared about the slope. But if we were going to graph, we'd want both of those components. So just to realize that's the form that we would want, that's our good form. When we want the equation of the line, this is where our point slope formula really comes in handy. And to use this formula, we always need 2 things. We always need a point and a slope. So every time we're asked this question, it's always a hunt for these 2 items so that we can use this equation. So for problem number 1, let's find the equation of the line that goes through the points -6, -1, and let's go -2, -5. We're given 2 points. Well, we always need a point and a slope. I've got 2 points, so I definitely have that covered. But what about the slope? Okay, I'm not giving you the slope. We had some problems where that was just handed to us. Here's a point, here's a slope. We could get right to plugging in. But in this one, we realize I have 2 points. I've got a formula that I could use to find slope in that situation. My formula, y2 minus y1 over x2 minus x1. This is where, everybody, we got to know these formulas, not just enough to flip back in our notes and find them. You don't get to bring an index card in on the test, but that's where we always say, for some people, just jot these formulas down right off the bat on the test. Make sure we don't goof like our minuses, our pluses, have the y's over the x's, not vice versa. But now that we have our formula, just plugging in. I intentionally picked one with a lot of negatives here. I'm sorry, this was a +5. -6, -1, and -2, +5. But I'll start with that y. So I'll go 5 minus a -1 over, now I have to use this x first on the bottom because I use this y first on the top. So that'll be -2 minus a -6. That becomes 5 plus 1. That's a 6. -2 plus 6 becomes a 4. And this is where, folks, 6 over 4 is pretty good, but so much better if we can reduce that and get that our slope is 3 over 2. And now, slope and a point. Or slope and a point. Either way, this is fine. And this is where also on our homework sheets, they've often given both directions. Give the point slope form and the slope intercept form. I've always said, as long as you just give me any equation, that's fine. But just to demonstrate that we'll get the same thing regardless, I'll start here. If I use this slope and this point with this formula, I'll get y minus a -1 equals m times x minus the x coordinate of -6. Again, good answer. But if you used this point and this slope, you would have y minus the y coordinate 5 equals m 3/2 times x minus the x coordinate -2. And again, both correct. You write either of these on the test, I'd have both of these on my answer key. These are correct. But if you really want to see they're the same, that's where we'll just solve for y. Put each of these into y equal mx plus b, and then we could see everything all lines up. Over here, that becomes y plus 1. That becomes a plus 6. I'll distribute the 3 halves. 3 halves x. 3 halves times positive 6 becomes 18 over 2. That's a 9. Subtract 1 from both sides. I get 3 halves x plus 8. Over here, exact same situation. That's already clean. Over here, that'll become a plus when I clean up those negatives. Distribute the 3 halves. Y minus 5. Over here, 3 halves times x. Again, that's a plus 2. 3 over 2 times positive 2. 2's cancel, just left with the 3. Add 5 on both sides. And we're right back where we were over here. That we see over here, we add the 5, and we're getting that 3 halves x plus 8, just like we had over here. So, good first start. Let's take it to the next level, right? Still finding the equation of a line, but now number 2, and this is where we'll do 2 parts here. Let's find the equation of the line that goes through the point. We'll go 6 comma minus 2, goes through that point, and is parallel to 2x minus 3y equals negative 12. In a few moments, we'll come back and we'll redo it as perpendicular to this line instead of parallel, but let's start here. What do I know? Well, I still want the equation of a line. I'm still looking for all of this. So I come down here. What is it that I already know? Well, I do have a point, so I've got my point covered. What about my slope? Well, over here, we were given 2 points. We could find the slope. Over here, we're given this information about a parallel line. And this is why we just did that first exercise. If I know the slope of this line, I can figure out the slope of my line because it's parallel. So how do I figure out the slope from this line? Let's put this into mx plus b form. I'll subtract the 2x from both sides. I'm going to come and do my work over here. So minus 3y is left. Don't forget that negative. The 2x's cancel, but the negative is still attached to the 3y. On the other side, again, technically minus 12 minus 2x is good, but we'd rather write it this way just so that we keep the x first, because mx plus b starts with the x term. Divide everything by negative 3. Clean y over here. Negative 2 divided by negative 3. Well, I can't reduce that fraction, but I don't want to leave the 2 negatives. That becomes a positive 2/3. And then minus 12 divided by minus 3 is positive 4. Okay. We've got this line in this form. So what is the slope of this line? There it is. The slope is 2/3. And since my line is parallel to this line, my line also has a slope of 2/3. There's my point. There's my slope. I'm going to come right here and put it together. Y minus the y coordinate equals m times x minus the x coordinate. And as I keep saying, a perfectly good answer, but even if you're just checking your answers in the book, they mostly clean them up, solve for y. And I always say in class, it's just good practice. Distribute this here, clean this up here. This is y plus 2 over here, 2/3 x. I get 2 times 6 is 12. 12 divided by 3 is 4, still negative. Subtract my 2. Y equals 2/3 x minus 6. If I was going to graph it, I'd want that form. But again, we just wanted the equation. So that was a good answer, and so is that. But now, before I move on here, one quick little change. I still want to talk about the line that goes through this point, but let's just make a quick change. What if I wanted the line that was perpendicular to this one? The process is almost exactly the same. I'd still need to know the slope of this line so I could figure out the slope of my line. So to figure out the slope of this line, I'd solve for y, exactly as we did here. We'd get that the slope of this line is the positive 2/3, just like we had before. But now we'd say my line, our line, is perpendicular to this one. So our line would have a slope -3/2. That's where we're using the negative reciprocal. Point, slope. Now I would just come down here, y minus the y coordinate equals my new slope, -3/2 times x minus the x. And this one I'm just going to leave. Again, you could keep solving this one for y as well. Again, always good practice. Realize, folks, this is now a new question. It's not like this one up here where we just did the same problem with 2 different points and we expected to get the same answer at the end. Here, this was literally 2 different questions when we were asking parallel versus perpendicular. That was a separate question, so I'm not expecting to get the same answer here. Last one. We are still finding the equation of the line, but now let's wrap this up with some of those goofy cases. Number 3. Let's find the equation of the line that is parallel to y equals 7 and goes through the point, let's go 2, -4. Why is this one a little different? I mean, it's still a find the equation of a line, so it still feels like, well, we should do it the exact same way as the previous. We should be focused on this. But this is where just the special cases have to click in for a moment. That if we really try to take that exact same approach as before, well, I've got my point. How do I get my slope? Well, I still got to recognize something's weird here. Either I can force this into mx plus b, thinking of it as 0x plus b, so that the 7 is the b, and we've got a 0 for the slope, or we just recognize that's a little weird. And especially in the weird cases, sometimes a quick picture can really, really help. So let's just see this for a moment. What does this line look like? Y equals 7, 1, 2, 3, 4, 5, 6, 7, would be up here and would look like that. The point, 2, -4, 1, 2, down 4, would be about here. What is the line that goes through that point that's parallel to that one? See, if we just look at it, we can see it. Oh, if it's parallel to this one, it can't ever touch, so it's got to do the same thing. It's got to do that. So if I start with a horizontal line, the line that's parallel to it is still horizontal, and then it's going through this point. Well, all we really care about a horizontal line is its y value, whether I'm here or here or here, and the y value always here is -4. And that's it. That's all there is to it. So again, you could, if you're lucky enough that you could put all those pieces together, think of this as 0x plus 7, m equals 0. Well, parallel lines have the same slope, so you could force this one to work. But it's definitely a little easier to be able to see what's happening. And that's kind of what we've always said about those special cases. Just recognizing you're in the special case situation can normally be enough just to visually cue us into what comes next. And same thing in this last one, everybody. Just like before, I'm just going to swap that. Instead of parallel, we're going to look at the perpendicular line to this one. And this is where it gets so messy, because even if I was able to think of this line in this form and think of the slope as 0, well, perpendicular, I'd have a -1/0 slope. That's just weird. And again, maybe that cues us into the undefined slope, but that's where, once again, just thinking of the picture, still have the same y equals 7. That's the point I care about, but this time I want a perpendicular line that goes through this point to this line. Well, then it has to be this. Sorry, my line's a little sloppy there, but it's just supposed to be that vertical line straight up down. It goes through this point. It hits that line at a right angle. That's the perpendicular line. Well, now that we actually see it, we can see that line is vertical. What do we care about with vertical lines? We just care about the x coordinate everywhere. And whether you look here or here or here, we get x is always 2. So for the perpendicular, we got x is 2. So that's just a quick review from section 5. Make sure you also watch the video that goes with section 8. That'll be the new material that we'll get into next week.